Find an expression for the function that is the line segment joining -5, 10 and 7, -10. We're talking about a line segment, and so we are going to use the equation of a line, y equals mx plus b. This is this is slope-intercept form. We could also use point-slope form, which is y minus y1 is equal to m times the quantity of x minus x1. I really don't care which one you use. I will typically use y equals mx plus b because it's a little bit simpler. In either case, we're going to need a slope. Remember, slope is rise over run, and so we're going to take the difference of the y values, 10 minus -10, divided by the difference in the x values, -5 minus 7. And after simplifying, we get that the slope is -5/3. I'll then use xy as -5, 10, and m is equal to -5/3 into y equals mx plus b. And I get 10 is equal to -5/3 times -5 plus b, and now we just need to solve for b. A couple of algebraic steps gives me that b is equal to 5/3, and so we have y is equal to -5/3 x plus 5/3. And you can check that -5, 10 is on this line and that 7, -10 is on this line, but this is the entire line. We're looking for a line segment. So the expression that gives us, I'm going to say f of x is equal to -5/3 x plus 5/3, which is still the full entire line, but I only want the part between x equals -5 and x equals 7. You see, that's what's going to chop it into a line segment. And so here I'm going to say f of x equals -5/3 x plus 5/3, comma, -5 less than or equal to x less than or equal to 7. Or if I were talking like a normal person, I'd say f of x is the expression where x is between -5 and 7 inclusive, to say that we are including the endpoints there. Next up, find a formula for the function and state its domain. We're looking at a rectangle has an area of 16 square meters. Express the perimeter of the rectangle as a function of the length of one of its sides. So here we've got two things. We're looking for the perimeter of a rectangle, and we know that the perimeter of a rectangle would be p is equal to twice length plus twice width, or 2l plus 2w. This is a function, but it takes in two variables, L and W. In multivariable calculus is third semester calculus, we want this to be single variable calculus. So we want to express the rectangle as the perimeter of the rectangle as a function of the length of one of its sides. That as a function of is really important, because that's telling me when I write down my ultimate answer, p of something, that as a function of, that's what's going to go in the parentheses. And I generally wouldn't care if it was the L or the W, but we see as a function of the length of one of its sides. So what I really want here is P of L. So I'm going to identify that. I want P of L. That's because I'm being told to find it that way. So that's the model that we're after here. Or the model is P equals 2L plus 2W. I want to be able to express that model in terms only of L. That model is going to be subject to a constraint, and that is that we have a rectangle with an area of 16 square meters. And a constraint is really a relationship between two variables. And in this case, if the area is going to be 16 square meters, we know that the area of a rectangle is length times width is equal to area, and in this case, length times width is equal to 16. Now remember, I wanted to be able to express the perimeter of the rectangle as a function of the length of one of its sides, and so I want to solve for W so that I can get rid of W in the expression for perimeter, right? Since I want P of L, that means we want to get rid of the W. And in order to get rid of W, I solve for W. So here, I see that W is equal to 16 divided by L. Now I can express P of L as 2L plus 2 times 16 over L, right? So I've replaced W by 16 over L. And I'll tidy this up to say P of L is equal to 2L plus 32 over L. We were asked for the domain of this function, and here we see that L cannot be 0. But we also know that a rectangle can't have a length that is a negative number, right? So just practically speaking, it doesn't make sense. So here we're going to say that L is greater than 0 as the domain of this function. That's what's referred to as an implied domain. It is implied for the physical situation that we're looking at.